Irfan, is that clear?
Yes, sir.
I forgot to record the earlier part. Now I turn on the recording. Okay, তাহলে এটা হচ্ছে তোমার relationship between different types of average product, marginal product, and total product. Now, and also by looking at the values, এই ভ্যালুগুলো দেখে you can speculate what is the range you're in, okay, whether you're in diminishing or increasing or negative returns. Now, what do you want to do actually? Whenever you are expanding your company, you're scaling up your company, you're constantly watchful about how the scaling is working. Okay, so if you increase the input, is the output increasing? Okay, so you are always constantly seeing if the system is returning you good or bad. All right, you're constantly thinking about this is your system or your production system, and if you increase your input, to small to high, you want to see what is happening to the output, to the production. Okay, so how the system is returning, that is called the effect of returning to scale, right? If you scale up, what is the return? All right, this basically this is a metric. It measures the output effect of increasing all inputs. If you have one input, you increase that. If you have another input too, you also increase that simultaneously. Okay, মনে করো তুমি একটা গার্মেন্টস কোম্পানিতে আছো, you need to input labor and capital, or in our case, so you increase both of them. For example, let's go back to this one. You had one people working, one, you had an output of 5, right? If you go to 2 and 2, how much you get? You actually produce 21 units, right? So this is called effect of return to scale. That means you scale up the inputs by a factor of 2, you multiply by 2 in both the inputs, and what is the output you gain? For example, you multiply this 2 by another 2 and you jump to 4. এখান থেকে 4 এ চলে গেলা, and if you are at 4, you produce 77. So what is happening? তুমি যদি ইনপুটকে ডাবল করো, তাহলে আউটপুট হচ্ছে 4 times, right? If you make the input 4 times, does the output become 4 times, or it becomes more than that? এই ছবিতে কি বোঝা যাচ্ছে? যখন তোমার ইনপুট ছিল 1 1, তখন ছিল 5. Can you see 5? ফলো করতে পারছো?
Yes, sir.
আচ্ছা, যখন 1 1 ছিল তখন ছিল 5. Okay, let's look at a cleaner picture. Otherwise, I think it becomes clumsy. And most of you are staying quiet. And if you're quiet, it slows down the progress. Look at this. When you had 1 and 1, the output was 5. Okay? So, if you have to write it like this, function of 1 comma 1 gives an output of 5, and function of 2 comma 2 gives an output what? 31. And function of 4 comma 4 gives an output of 4. So that is 77. So you have an output of 77. So what's happening actually is how much is the increment in the output? This is more than 6 times, right? 6 times. And this is 14 times. More than 14 times, 15 times. More than 15 times, right? Let's. Okay, this is actually more than 15 times. তাহলে কি হচ্ছে তুমি ইনপুটকে যদি গুণ দাও ইনপুটকে যদি তুমি যা দিয়ে গুণ দিবা আউটপুট তার চেয়ে বেশি গুণে বাড়ে this is known as increasing return to scale okay this is known as increasing if the output increases more than the input increase factor then this is known as increasing returns to scale ফলো করতে পারছো কিনা increasing ঠিক আছে আর যদি উল্টোটা হয় now why are we looking to this kind of behavior and relationship because you want to understand what you have to do and which path you have to take to grow your business okay you have to understand at what input point you can double triple your inputs and see the similar kind of output increment or better if it worse then you don't take that path so this is called increasing returns to scale and if you see something otherwise it's called decreasing returns to scale okay the input সমান থাকে let's take a production function let's take a function let's say you have a function like this root over lk q equal to root over lk this is the production function this is the production function now if you double the input what will happen let's say this was the initial case and you want to double the input you double the input right instead of l you input 2l instead of k you are inputting 2k and the function remains the same okay so as a matter of fact you are doing this 2k 2l okay and that's how you get this what is the answer 2l k that means you have 2 times of q1 right so what happened you had a factor of 2 in the input section and that same factor you returned in the output দ্বিগুণ করেছিল input outputও দ্বিগুণ হয়েছে and this is known as returns to scale constant constant কেন কারণ ইনপুট দ্বিগুণ করলে আউটপুট দ্বিগুণ হয় ইনপুটকে 4 গুণ করলে আউটপুটও 4 গুণ হয় make sense that's how the returns to scale scaling effect is returning in constantly the same
স্যার একটা ইনপুট যদি বেশি বাড়ায় আর একটা কম বাড়ায় তাইলে কি হবে?
No,
মানে একটা
that is not how you measure the returns to scale, right? The definition of checking the return effect of returns to scale is you scale up both of the inputs. Okay? It is a
জি
definition. That is the definition of this observation. Now, what you just ask is basically returns to a factor. If you increase one factor, for example, you increase L or K, that measures output effect of increasing one input. Okay? We'll study both of them in the later slides. Let's see. You have gone through the definition already. Okay. And you have also gone through this one. We talked about it. Now, we had already discussed about isoquants, right? Mone ache isoquant ki jinish? Did we discuss about isoquants? I think no, we did not discuss about isoquant. We discussed about isoquant in the other classes, not in your class. All right. So let's observe what are those isoquants. Okay. Let's make a copy of this one. Make a copy. And it's right there. You don't want to see. Okay. All right. Okay. এখন this was the L axis, this was the K axis. Now try to identify the output levels that are equal to each other. Let's watch. See that? 68, 68, 68, right? All these outputs are same. And also you have one output, this is 67. This is very close to 68. All right? And you can also count 66 because these are all close to each other, right? Let's say that you want to draw a line. You want to draw a line joining them. Okay? And try to identify another one. Let's say we're using red color and we want to identify 99. We have 199 there. 99, and let's count 97 also because it's close to 99. Let's join these lines. If we may also identify another line. Let's say 127. Let's use green color. 127, 127, and this is 126. That's close. So we can also include 125. So we have a curve there, right? Can you all follow?
Yes, sir.
That's very good. All right, let's try to identify another line. Okay, let's identify this one. Let's say that we are running out of colors. Let's say we want to identify something around 91. 91, see 92, count that, 91. Let's say 91, 90, 89. Okay, let's count that, 89. So if you want to connect these lines, you see a curve, right? Everybody can follow? দেখতে পাচ্ছ সবাই?
জি স্যার।
Yes, sir.
এখন what is happening on these lines? What do you see? On these lines, the output is same, but the input has different combinations, right? How about this point? This is 91, and you can produce 91 units of breads by 8 ovens. All right, 8 of the oven. This is 91. We're looking at 91. And how many labor you need? 3. Okay, and you can produce the same output by using 4 of the machines, 4 ovens, and only 6 of the labor, right? If you increase the labor and you decrease the capital, you see that the output level remains same. Okay, and this output layer, these lines, basically these lines are known as isoquant. Isoquant line. Follow করতে পারছো? Isoquant line. Isoquant line মানে কি? Iso means equal. Iso means equal, and quant is actually quantity. ঠিক আছে? So এরকম যে লাইনগুলো আছে সেই লাইনগুলোতে তোমার output quantity is same. The same thing is happening over there. Now, if you look at the top, from the top to the bottom, একদম উপর থেকে নিচের দিকে তাকাবা, তাহলে কি দেখতে পাবা? You'll get to see these lines one after another, and if you project these lines on this LK plane, তাহলে কেমন দেখাবে? প্রজেক্ট করা মানে তুমি উপর দিকে তাকাচ্ছ, তাকিয়ে এই LK প্লেনের উপরে এদের ছায়াগুলো ফেলছো। Let's say you shine some light, torch light. কল্পনা করতে পারলে বলবা, স্যার কিছু বুঝতে পারছি না। টর্চ লাইটে আলো ফেলা হলো এখানে, তাহলে কি হবে? এই যে লাইনটা, এই লাইনটা শ্যাডো আসবে না এখানে, এখানে নিচে? If you look at the shadows, this is your L. You'll have to be a little bit of imaginative. Okay, একটু imagination use করলে দেখবা যে you can make a lot of sense. Now, what you see is the first line. Okay, and then you'll see this orange line. All right, and then you see this red line, and the green line will be farther away and the smallest one. Make sense? বোঝা যাচ্ছে কিনা?
Yes, sir.
আচ্ছা, now let's write these. Let's say you are at 90. Okay, and for this one you had 99, and for the green line you had 127, and this green this blue cyan one was 68. ঠিক আছে, ফলো করতে পারছো সবাই? Let's try to, oh sorry, let us draw a nicer picture. We will erase this. Use the scale. এক সেকেন্ড, হ্যাঁ go ahead. কার কোশ্চেন ছিল?
আমার ছিল স্যার। স্যার প্রজেকশনটা কোন
প্রজেকশনটা
মানে কোন বেসিসে প্রজেকশন হরিজন্টাল নাকি ভার্টিক্যাল?
You are basically projecting. Let me draw this, and then I'm trying to show you the other picture, and then your projection will be clearer to you. Okay. So this is your L axis, this is your K axis, and you're trying to project কোথা থেকে? তুমি উপর থেকে লাইট ফেলছো, ঠিক আছে, লুক এট দ্য অ্যারো, উপর থেকে লাইট ফেলছো, লাইট ফেলে এই এল কে প্লেন যেটা আছে এই প্লেনের উপরে তুমি এই লাইনগুলোকে তুমি শো করতে যাচ্ছ। এই লাইনে যে ছায়া পড়বে এল কে প্লেনে, দ্যাটস হোয়াট ইউ আর ড্রয়িং হিয়ার।
জি স্যার বুঝছি।
আচ্ছা, সবাই ফলো করছো এখন? So these lines are known as isoquant line. Okay, কারণ আইসোকন্ট লাইনের মধ্যে এই লাইনের গ্রিন লাইনের আউটপুট সবচেয়ে বেশি, 68 সবচেয়ে কম। and you see this is the origin 00, right? অরিজিন থেকে যত দূরে যাচ্ছ তত হচ্ছে আইসোকন্টের আউটপুটের ভ্যালু বেশি। Output is higher when you further move away from the origin. See that? Now if you want to expand your business, let's say you are operating at this point, okay, and if you want to expand it, you will be going to jumping to this one, and then you jump to this one, and then you jump to this one. This is what actually what you want to do, right? Now the question is whether you want to operate here or there. এখানে এ পয়েন্টে অপারেট করতে চাও, বি তে করতে চাও, নাকি সি তে করতে চাও, না এ প্রাইমে করতে চাও, না বি প্রাইমে করতে চাও, না সি প্রাইমে করতে চাও, or if you want to do it C double prime or at B double prime or at A double prime. That is the question. Can you follow? এটা কোন কোশ্চেনটা? This is the same question we translated in a different format just. This is the question, sorry. This is the question. Remember এটা আগের দিন লিখেছিলাম আমরা। What is the best way to scale up keeping the cost low and profit high? We are trying to scale up. এখন where would you operate on an isoquant line should be directed by your desire to keep the cost low and keep the profit high, right? Make sense? বোঝা যাচ্ছে? কারণ তুমি একটা ব্যাপারটা এরকম, তুমি একটা উপরে উঁচু জায়গাতে ওঠার জন্য সিঁড়ির স্টেপগুলো তুমি আইডেন্টিফাই করেছো। These are the steps of your staircase to reach this height. কিন্তু সিঁড়ি তুমি কোথায় পা ফেলবা? এখানে পা ফেলবা না এই পাশে পা ফেলবা? তারপরের স্টেপটা কোথায় ফেলবা? এখানে ফেলবা না এখানে ফেলবা? That should be decided by wherever you can operate at the lowest cost. Is that clear?
জি স্যার।
যেখানে অপারেট করে কস্ট লো হবে সেইখানে তুমি অপারেট করবা। Okay? Then we'll try to look into which should be your appropriate point of operation in the next graph. But now, for now, remember that these are isoquant lines. Isoquant lines means wherever the quantity of output is same. Okay? The output quantity is same. Now, if you want to see, okay, let's also look at one of the lines. Let's only observe the 68, right? Isoquant 68. This is 68. L, K, 00 origin. Now, if you want to plot different points of 68, what do you get? You're trying to collect the values from here. 68. Labor equal to 3. Capital equal to 4. That gives 68. So let's do this. 1, 2, 3, 4, 5. 1, 2, 3, 4. So labor equal to 3 and capital equal to what? we're looking at this point. This is 4 versus 3. So 4, 1, 2, 3, 4 at this level, and let's say 1, 2, 3. Okay, now we have to adjust this a little bit. We have to redraw it. Let's do that. So now the eraser is not working. Okay. All right. So let's draw it like this. তাহলে কি হলো? এটা হচ্ছে k equal to 4, l equal to 3. At this point, you have an intersection. And what else you have? The next one is 3, k equal to 3, l equal to 4. So you have k equal to 3, l equal to 4. 4, 3. Let's say this is another point, this is another point. What's the third one? The third one is here, k equal to 2, l equal to 5. So you have k equal to 2 and l equal to, where is it? 5. Let's say this is 5. We are now drawing this up to the scale, as you can clearly see. But let's say this is another point, okay? ঠিক আছে? Let me know if you can follow it or not. So this was our point A. This is point A, B, and C, as they all correspond to these points. This is A, B, and C. Can you follow? এখান থেকে আমরা তুমি এটাকে নিয়ে এসছো এখানে, ঠিক আছে? Now the question is, where would you like to operate? That is the question. Whether you want to operate at A point, B point, or C point. How will you decide? তোমার হাঞ্চ কি বলে? কোন জায়গায় অপারেট করা বেস্ট? Because wherever you operate, the output is same, 68. তুমি মানুষ বেশি নিয়ে তুমি ওভেন বেশি কম নাও, অথবা ওভেন বেশি নিয়ে মানুষ কম নাও, তুমি 68টা কেক প্রডিউস করবা। 68 cakes, whichever point you operate. So the question is, which one should be your operation point?
স্যার দুইটার কি কস্ট একই, মানে ওভেন বাড়াইতে আমার যে কস্ট আর মানুষের স্যালারিতে যে কস্ট?
Exactly. You would have to look into the cost. Okay. And look at another point. You can easily substitute. Some people by labor, right? Because your output is same. Or যদি 5 জন মানুষ থাকে, তো 5 জন মানুষকে তুমি হায়ার করতে পারো, তুমি দুজনকে লোক কমায় দিতে পারো, দুজন লোক কমায় দিয়ে you can increase your machine by 2, right? So when you're operating on an isopon line, the point of discussion of substitution comes, right? Substitution. কতগুলো লোক দিয়ে কতগুলো লোক তুমি চেঞ্জ করতে পারো, that is where you have to think about now. কারণটা কি? তুমি এক পয়েন্ট থেকে অন্য পয়েন্টে অপারেট করার জন্য জাম্প করতে হলে তোমার আইদার মেশিন বাড়াতে হবে or লেবার বাড়াতে হবে, if you want to keep your output same. Okay, so how much you can substitute, how much of labor? Let's try to draw this line. bit differently. একটু extend করে ফেলি, হ্যাঁ? তোমাদের জন্য জিনিসটা easy হবে। Let's say that you have extended the line like this, and so much so that if you are using only one of capital and square, I don't know, maybe 8, 7, 6, 7, 8, huh? You need 8 people. তোমার কোম্পানিতে 8 জন লোককে কাজ দিতে হয়, কাজ করতে হয়, যেখানে তুমি পয়েন্ট ডি তে অপারেট করো, বাট তোমার ক্যাপিটাল একটাই লাগছে, একটা, ঠিক আছে? So if you are operating at point D with only one oven and 8 people, you're producing the same output at 68. So তুমি যেটা করতে পারো যে if you increase one machine, একটা oven বাড়িয়ে ফেললা, you go from 1 to 2, and you can immediately release so much of labor expenditure. From 8 you can go to 5. ঠিক আছে? So what do you think? Is it beneficial to reduce people and increase capital at this point? যদি D তে অপারেট করো তাহলে তুমি একটা মেশিন বাড়ালেই you can reduce so much of labor. You can save a lot of cost here. Okay? So now you have a motivation to reduce the labor by increasing your capital. You can save some labor. So this point is known as labor saving. কারণটা যে পয়েন্টে অপারেট করে তুমি small increment of capital allows you to save a lot of labor. That is called labor saving point. And if there is another operational point right there, somewhere up there, let's say A, B, C, D, E, let's say there's another point E, and A point যদি এমন হয়, you have only one person working, and we are trying to guess all of that. It doesn't have to be, mathematically correct. And let's say you have 8 capital at this point. So what do you want to do? If you increase, let's say this is your 2, and the next operating point would be 5, this is F. ঠিক আছে? তুমি যদি, if you are operating at point E with 8 capital and only one labor, তুমি যদি এখানে labor একটা বাড়াও, you go from 1 to 2, what happens? You immediately jump from the point E to point F, and at point F, from the capital's point of view, you have a significant saving of 3, and you can operate at 5 capital, তাই না? ঠিক আছে? তুমি শুধুমাত্র লেবার একটা ইনক্রিজ করছো, you are increasing only one labor, and you are able to save 3 capitals. So this point, you can, if you do this substitution, you can save capital at this point. So this point of operation is known as capital saving. Capital saving substitution, or you can say that this is capital saving operation. বুঝা যাচ্ছে? Making sense?
জি স্যার।
জি স্যার।
Acha. Now you are doing this visually by looking at it with your eyes, right? The way to do that mathematically is you try to see what is the rate of substitution. Rate of substitution. You want to find out the rate of substitution. And more appropriately, you want to find out marginal rate, delta rate of substitution. This is called marginal rate of technical substitution. And in short, this is known as MRTS. And you are basically substituting MRTS L for K. So this is how you calculate marginal product of L divided by marginal product of K. And that gives you a good sense what you have to substitute. For example, if you have a high value of marginal MRTS LK, that means you have higher MTL, okay? Marginal rate of product of L, if this is higher, then marginal rate of capital, okay? তার মানে কি? With every increment of one labor, your output jumps higher. Can you see this? MTL, let's say if in some case MTL is higher than MPK, তার মানে কি হবে? এক ইউনিট লেবার বাড়ালে আউটপুট বেশি বাড়ে, তাই না? Output jumps more with increment of L. Then output jumps with increment of K. তাহলে কি হবে? এই সিচুয়েশনে তুমি কি করতে চাও? লেবার বাড়াবা না ক্যাপিটাল বাড়াবা? কোশ্চেনটা ক্লিয়ার হয়েছে? মনে করো একটা লেবার বাড়ালে আউটপুট বাড়ে 10 আর একটা ক্যাপিটাল বাড়ালে আউটপুট বাড়ে 1। লেবার যদি 1 বাড়াও তাহলে আউটপুট বাড়ে মনে করো 10 ইউনিট, ঠিক আছে? একটা যদি ক্যাপিটাল বাড়াও তাহলে আউটপুট বাড়ে মনে করো 5 ইউনিট। তাহলে এই অবস্থায় তুমি কি করতে চাও? কোনটা বাড়াবা? লেবার বাড়াবা, রাইট? এখন যদি বলতে হয় আচ্ছা লেবার যা আছে, ক্যাপিটাল যা আছে সেখান থেকে কমাতে হবে অথবা লেবার থেকে কমাতে হবে, একটা থেকে কমায় একটাকে দেওয়া যাবে, ঠিক আছে? এখান থেকে কমায় এখানে দেওয়া যাবে অথবা এইখান থেকে কমিয়ে এখানে দেওয়া যাবে, তাতে যেন তোমার আউটপুট, টোটাল আউটপুট কিউ ইকুয়াল টু সেম থাকে। তখন তুমি কোনটা কমাবা, কোনটা সেভ করবা?
লেবার কমাতে
তোমার আউটপুট সেম রাখতে হবে, এখন কস্ট সেভ করতে হবে।
লেবার বেশি
তুমি দেখলা যে you look at this labor, that labor has higher impact. labor 1 বাড়ালেই 10টা করে বেড়ে যায়, আর কিন্তু ক্যাপিটাল, if you increase capital it only increases 5, so you have to keep this q same. তার মানে কি তুমি কোনটা বাড়াবা কোনটা কমাবা? ফলো করতে পারছো সবাই?
জি স্যার। স্যার লাস্টেরটা একবার রিপিট করলে।
আচ্ছা,
বুঝি
কোশ্চেনটা হচ্ছে মনে করো এটা তোমার আউটপুট লেভেল, হ্যাঁ? এটা বার চার্টে দেখাচ্ছি, এটা হচ্ছে আউটপুট 68, ঠিক আছে? এই আউটপুটটার কম্বিনেশনটা হচ্ছে মনে করো এখানে 10টা, মনে করো ক্যাপিটাল আছে 2টা, লেবার আছে ধরো 1টা, ঠিক আছে? এদের কন্ট্রিবিউশন এরকম, একটা লেবার তোমার আউটপুটের, আরো সহজ করি, তাই না? একটু সহজ করি, 68 না, মনে করো টোটাল তোমার আউটপুট হচ্ছে তোমার 20, এল 20, L1 একটা L এর ফলে তুমি এখানে 10 পেয়েছো, দুইটা K এর ফলে এখানে 10 পেয়েছো, ঠিক আছে? এখন তোমাকে যদি বলা হয় যে আউটপুট সেম রাখতে হবে, তুমি কি করবা?
দুইটা কে সরায় একটা এল বাড়াবো।
এক্স্যাক্টলি, তুমি কি করবা? পুরাটা K একটা বাদ দিয়ে দিবা, বাদ দিয়ে বলবা যে এলটাকে 2 করে দিই, তাহলে পুরোটাই হচ্ছে হেলদি হয়ে যাবে। তাহলে কি হবে কি, at this operating point তুমি কি করছো? You're basically trying to save the capital, তাই না? So you're trying to save capital. Is it making sense? বুঝতে পারছো এখন?
জি স্যার।
So এখন তাহলে কি হলো, going back to this, if you find your MRTS LK, MRTS যেটা ডেফিনেশন হচ্ছে MPL ডিভাইড বাই MPK, এইটা যদি একের চেয়ে বড় হয়, if it's greater than 1, what can you say?
ক্যাপিটাল সেভিং।
This is capital saving. আর যদি উল্টা হয়, if this is less than 1,
আর লেবার
তাহলে labor saving. আর যদি equal to 1 হয়, তাহলে it doesn't matter, neutral. It doesn't save. It doesn't indicate you have to save something. এটা clear? ঠিক আছে? Before you dive into the mathematics, understand the concept. পরিষ্কার হয়েছে? আমি জিজ্ঞাসা করবো কাউকে?
স্যার ইকুয়ালস টু 1
হ্যাঁ, equals to 1, equals to 1 যখন হচ্ছে তোমার marginal product of L তোমার marginal product of P এর সমান হবে। তার মানে তুমি যদি 1 ইউনিট লেবার বাড়াও, তাহলে আউটপুট যা বাড়বে 1 ইউনিট কে বাড়ালেও আউটপুট একই সমান বাড়বে। কাজেই তোমার দরকার নেই একটাকে কমায় একটাকে বাড়ানো, দুটোকে একই রকম বাড়াতে পারো, দুটোকে একই রকম কমাতে পারো। মেক সেন্স?
জি স্যার।
That means it doesn't bias you, it doesn't tell you to swing in one direction versus another direction. Okay, so just by looking at this marginal rate of technical return, just by looking at the definition and finding out the value of it with respect to 1, you can basically speculate this, whether you want to change labor or capital and so on. Now going back to this graph, whether you want to operate at point A or point B or point C, it has to do with replacing, substituting labor for capital or capital for labor, right? Because you want to keep the same output level. Now the question is, where would you like to operate, right? That is the question. We are constantly telling you the same question so that you don't forget. Now, তুমি যদি এটাকেই তাকাও, look at this MRTS LK. MRTS LK. Marginal rate of technical substitution, LK. The definition of marginal product of L divided by marginal product of K. If you plug in the values, the definition of marginal product of L and marginal product of K, you find this. Do you agree? The definition chilo, del Q by del L, del Q by del K. That was the definition of marginal product of labor and marginal product of capital, respectively. So now, if you do the simplification, what do you find? Marginal product of K divided by marginal product of L. That is the definition of MRTS LK. So actually, what is this? this is nothing but a tangent on your isochron line. This Microsoft whiteboard is not responsive sometimes. Okay, এখন দেখো এটা কি যে কোনো একটা point. This is L and K, right? At any point, if you take the differentiation del K by del L, this is the tangent, right? Follow করতে পারছো? And this tangent is actually your MRTS LK. Okay? So তোমার কাজ হচ্ছে এত অঙ্ক টঙ্ক না করা। অঙ্ক না করে তুমি কি করবা? You look at the isochron line. Okay? You look at the isochron line, and whatever the operation of point of operation, you draw a tangent. Okay? If you see the value of tangent is less than 1, slope of the tangent, then you have to substitute your labor by capital, because this is what labor saving, right? আর যদি এখানে থাকে, you draw a tangent, তাহলে your MRTS LK is high. All right, this is high. That means this is greater than 1. So at this point you would be saving capital. That means you are at this point, you want to save some capital, go back, go below. So that means you're traveling towards this direction. So this will be a preferred operation point. Or if you want to really go for a better operation point, you would be looking like a point at this point. Okay? যেখানে তোমার MRTS LK is becoming equal to 1, sorry, not 0. It's equaling to 1, and at that point you will be saving some capital. আর তুমি যদি এখানে অপারেট করো, let's say this is your point A and this is B, C, এখানে অপারেট করলে your MRTS LK will be what? Labor saving. Yeah? So you will be traveling to this direction. Okay, so if you are operating at point B, that means this curve at this point you don't have any bias towards any labor saving or capital saving point. Okay, বোঝা যাচ্ছে এটা? And also, if you look at the graph, by looking at the curve, isochron lines, you can also tell a lot of things. Think about this situation. মনে করো তুমি তোমার গাড়ি চালাচ্ছ, গাড়ি অক্টেনেও চলে, গ্যাসেও চলে, ঠিক আছে? You have a limit of 250 kilometers you want to go. এখন তুমি তেলেও চালাতে পারো, গ্যাসেও চালাতে পারো, ঠিক আছে? That means your isochron line will be a straight line, right? So let us say that তোমার গ্যাস 1 কিলোমিটার তেলে কতটুকু গাড়ি যায়? ধরো 10 কিলোমিটার যায়, ঠিক আছে? 10 kilometer যায় 1 kilometer oil, হ্যাঁ? So let's use for oil, let's use L, okay? আর গ্যাসের জন্য G ইউজ করি, তাহলে 10 into L, right? প্রতি লিটার তেলে 10 কিলোমিটার যাবে। আর ধরো প্রতি লিটার গ্যাসে মনে করো একটু বেশি করি, মনে করো 100 কিলোমিটার যাবে এটাতে, 100 না, Let's say this is 20. This is 20 and this is 10. And this has to be equal to 250. ফলো করতে পারছো এটা? মনে করো তুমি গাড়ি চালাচ্ছ, তোমার গাড়ি 20 কিলোমিটার যায় প্রতি লিটার তেলে, তাহলে 20 into that many liter, ঠিক আছে? And if you multiply 10 kilometers and to the number of gallons of gas, liters of gas, you get this many kilometers, and in total you want to go 150 kilometers. So this should be equal, and that's your equation. All right, this is your equation. And on this equation, any amount of L and or G you input, it should be always equal to 250, and this is nothing but a straight line, right? If you plot the straight line, let's say this is 250, this Q is 250. So you fall on a straight line, and there is no bias, there is no issue in substituting oil for gas. So your substitution is very easy. There is no problem. Okay, so if you find any isochron line, and on this point the output is same, right? যতটুকুই তেল অথবা গ্যাস পোড়াও না কেন গাড়ি 250 কিলোমিটার যাচ্ছে, the output is same. So this is an isochron line, and on this isochron line it looks like a straight line. There is abundant substitution. You can use any amount of gas or any amount of oil, octane, to drive that many kilometers. So this is a straight line, and the substitution is abundant. And there is another extreme example. মনে করো you're building bicycles, ঠিক আছে? বাইসাইকেল বানাতে কি লাগে? বাইসাইকেলের ফ্রেম দরকার, একটা ফ্রেম, এটা একটা চাকা, and you have to have a handle, right? So you need two wheels and one frame to produce one bicycle. তুমি যদি হুইলের সংখ্যা বাড়াও, হুইল মনে করো 4টা হুইল দিলা, কিন্তু ফ্রেম একটা, কয়টা বাইসাইকেল হবে? একটাই হবে. So you are going to this horizontal line, and if you go the other way around, if you keep the number of wheels same, and if you keep on increasing the frames, you still have one bicycle, right? So you see basically a rectangular shaped isochron line. All right, these are absolute impossible to substitute, and these are known as complements. একটা প্রোডাকশন ইনপুটের মধ্যে you have to consider these as complement, মানে একটা একটাকে বাদ দিয়ে you cannot produce an output. All right, and if you look at this, the isochron line, this is also an isochron line, and this line looks exactly L-shaped. It has a right angle at the knee. So this is another extreme case. Okay, so in between, in more natural situation, you have an isochron line which more looks like a C, English letter C এর মতো এরকম, হ্যাঁ? So you see this type of lines, and these are more practical lines. For example, you have a cloth and labor. This is the isochron line you see. ঠিক আছে? This is a typical substitution. And এই দুটো এক্সট্রিমের মধ্যে, within these two extremes, if your isochron line looks rather flat, then this is easy. All right, if your isochron lines looks like this is hard. This is hard to substitute. Because you see it looks rather more like a complement. Complement, you cannot substitute one for the other. But for this kind of hard substitution, you can do substitution, but it becomes difficult. Okay. So, and we have to look back into the definition of isochrone lines. Okay, there's another illustration here. Look at that. These are your isochrone lines, right? And but if your isochrone lines has a look like this, let's say it's a C-shaped line, and it curves upwards at this point. আরেকটু কার্ভ হয়ে উপরের দিকে চলে যাচ্ছে। তার মানে কি হচ্ছে, if you increase labor beyond this point, you need more capital. এর আগে কি হচ্ছিল, তুমি যখন এখানে আছো, তুমি যদি লেবার বাড়াও, তোমার ক্যাপিটাল কমে আসে, তাই না? লেবার বাড়াও, ক্যাপিটাল কমে আসে। This is the usual case, and vice versa. But beyond this point, in this region, if you increase your labor, instead of capital reducing, it's increasing. So this region is called inefficient region of production. Okay, you can find this kind of inefficient region of production at either side of the isochrone lines. Okay, all right. So just for the sake of mathematical rectification, your MRTS is, by definition, you have seen this, right? MPL by MPK, and you have also found this del K by del L, right? But if you look at this isochrone line, always if you take del K by del L, this will turn out to be negative in the most operational cases. ঠিক আছে, নেগেটিভ করে ফেলে এটাকে, কারণ because the slope is negative, এই কারণে। but your MRTS is always a positive quantity. MRTS হচ্ছে positive, ঠিক আছে? That's why you basically have to add a minus sign in front of this equation. Okay, so এটা একটু কেয়ারফুল থাকতে হবে, otherwise your math একটু ভুল হয়ে যেতে পারে। So when you are using this form of definition equation, add a minus sign over here. But if you are using this form of definition, it's perfectly okay, because all of these quantities are positive in most operational ranges. Okay, এখন there are so many stories of substitutions. You can find some video documentaries talking about how labor is going to substitution by machines. Okay, and this is not far away from us. This has been, I think, in 2015 and 16, there has been a presentation that they were trying to bring in industrial robots for garments industry in Bangladesh. Okay, so this is not a far-fetched situation. So we talked about marginal rate of technical substitution, right? We talked about that, and we talked about this very hard to substitute. And if you have isoquant lines like this, that means abundant substitution. This is something interesting to watch about. We talked about returns to scale. Okay, look at this graph. And this is the isoquant lines output. If you're on point, the lowest point, your output is Q equal to 100. If you double your input L to second 2 times, your output does not jump by 2 times. It becomes 140. If you triple your input L, you operate at point C, and you are on another isoquant line. You see that? You are not on the same isoquant line. If you are on a different isoquant line, in that case, your output is different. Okay, and also look at the effect of scaling. If you scale up, that means your output was 10 and 10, you were working on isoquant Q equal to 100. If you double it, okay, if you go to 20 and 20, you are basically operating at this point. So that means your output is doubling. Earlier it was 20, now it's doubling. Okay, if you make your inputs 3 times, if you go to 10 to 30, okay, you go 10 to 30, in that case you're basically jumping from this point on to this point. Your output is scaling up by 3 times. In this case, in this particular example, this is return to scale is what? Constant, right?
Yes.
And also watch this carefully. If you are increasing the inputs, at the very beginning you had 10 labor input increment and the increment was only 40. Then you had same amount of increment again, 10 input, 10 units more, and the increment further reduced, it became 170. 30 বেড়েছে. It increased only by 30. So initially it increased by 40 and then it increased by 30. Okay, so that means every time you increase one of the inputs, the output increment diminishes. Okay, so in this case the production function exhibits a constant return to scale but diminishing marginal returns to labor. This is what we were talking about in the slide that we talked about before. Okay, এইটুকু ক্লিয়ার হয়েছে কিনা? Is it clear for everybody? আচ্ছা, ধরো in some production system we talked about our bakery A and L. Let's say this is the isoquant line Q equal to 30. ঠিক আছে? Q equal to 30 and let's say we all are participating in it and we have 25 people. We have 25 capital and 25 people working and this is our operating point. Okay, point A. ঠিক আছে? But somehow let's say the technology changes. Technology change হয়ে গেল, we become more productive. আরো অনেক বেশি প্রডিউস করা যাচ্ছে। আমাদের 25 জন লোক মিলে আরো বেশি জিনিস প্রডিউস করা যাচ্ছে। ঠিক আছে? অন্যভাবে চিন্তা করো, মনে করো এই 30 unit, let's say everybody, let's use a different formula, all right, so that it will become more illustrative. Let us say that you are producing 25, okay, 25 জন লেবার, 25 জন ক্যাপিটাল থাকলে in that case you are producing 25 units of output. But all of a sudden, let's say there was a technological change, okay, technological change happened and everybody becomes very efficient. Now you no longer require 25 people and 25 capital to produce 25 output. Okay, instead of that you can produce, you need just only 10 people and 10 machines to produce that 25. This was the before graph. Okay, but because of technological change সবকিছু efficiency বেড়ে গেল, তার ফলে তুমি মাত্র 10 জন by using 10 capital and 10 labor you can produce the same output. Now you have a Q equal to 25 here. Okay, so now if you do plot it, it looks like this. Q equal to 25. Follow করতে পারছো? Can you follow?
Yes, sir.
Because people have become more efficient. You're producing the same amount by less amount of capital and labor. So what does it tell you? This was the curve before, this was after. After technological change, your isochron line, this isochron line moves close to the origin. Eta hocche origin, this is the origin. This was the isochron line before, and this is the isochron line after. So if the technological progress happens, then your isochron line moves close to the origin. So by looking at the isochron line before and after, you can easily identify what has happened. If the technology has progressed you, or it has taken you far, made you further inefficient. If you had a graph after the technological change, if you had a graph which looks like this, and your Q would be equal to 25, তার মানে কি? তার মানে মনে করো তোমার এখানে এই জায়গাটা ইন্টারসেক্ট হচ্ছে, ঠিক আছে? এখানে হচ্ছে, মনে করো তোমার লাগছে 30টা লেবার লাগছে, আর এখানে ইউ আর রিকোয়ারিং লেটস সে 35, 30 capital, and you require 35 labor, and you're intersecting at this point and still producing 25. What does it mean? That means whatever technological change has happened, you did not progress. You basically had reverse progress, opposite of progress, right? So if your technological change progresses you forward, you will see your isochron line. This is an isochron line. It is moving closer to the origin, or your isochron line is moving closer to the origin, or if it's not progressing you, in that case you will see your isochron line taking you to the opposite direction from the origin. Okay, so by looking at the movement of the isochron line, you can tell whether some kind of technological progress has happened or not. All right, now another important interesting understanding. Let's say you draw two isochron lines. Let's use this figure. Two isochron lines, right? And both of them, this one was before the technological change happened. This is before the progress, and this one is after the progress. So obviously this will be closer to the origin. Now let's say before the progress, this was your point of operation. This was your point of operation. Okay, you draw a line connecting this point and point A, and you see this point cuts the new operation point, new isochron line at point B. Okay, এখন তুমি যদি এই পয়েন্টে একটা tangent draw করো, what does it mean? This is MRTS, right? Based on the definition, because MRTS is what? Del K by del L, right? So this is actually a tangent. Okay, এখন the tangent you see before technological change is same and parallel to the tangent you see after the technological change. That means কি হয়েছে? MRTS এর value change হয়নি, তাই না? So MRTS remain constant. Over the technological change. So if MRTS remains constant, that means the technological change is not biasing you to save labor or versus capital. Can you follow?
Yes, sir.
শুনতে পাচ্ছো? আচ্ছা, good. আর যদি অন্যরকম হয়, মনে করো this is before, this is after, and this is the MRTS. The MRTS value before is larger than the MRTS value after, right? এটা হচ্ছে MRTS কম. In that case, this is a labor saving technological progress. কারণ if you have MRTS LK যখন কমে যায়, this is labor saving. Based on our earlier discussion, and if the opposite thing happens, if the tangent becomes sharper, the MRTS increases, that means this is a capital saving technological progress. ঠিক আছে? In realistic world, মনে করো তুমি সবকিছু হাতে করতা, হাতে তুমি কেক বানাতা, and all of a sudden now you found a mixer in the dough mixture in or maybe egg beater, electric egg beater at the store. You get an electric egg beater, now you require less number of people. ঠিক আছে? Thinking about your bakery. So if that happens, that means you can save labor by replacing. Maybe your operation point has become something like this, and you can save and move upwards. Save the labor and move upwards somewhere here and use more of the machine and save the labor. If the opposite thing happens, it can also happen. In that case, you move further down and increase labor and save the capital. Okay? Just by looking at the graph and the tangents, looking at the intersecting point, you can tell what is happening. Now, going back to the question we started off. ঠিক আছে? আমরা যে কোশ্চেন নিয়ে স্টার্ট করেছিলাম, সেই কোশ্চেনটা হচ্ছে কেমন করে you have to expand, right? And we thought about this, where to operate, at this point, or at this point. কোন পয়েন্টে অপারেট করতে হবে? Okay, let us say that you have 4 units, 1 unit, you have let's say 2, and you have 2, and for example, let's say you have 1 and this one is 3, 4, 5. Okay, these are point A, B, and C. কোন জায়গায় অপারেট করতে হবে? Let's say the labor cost. Let's look at the cost market. Okay, let us say that you would be you would have একজন লেবারকে বেতন দিতে হয় মনে করো 100 টাকা, ঠিক আছে, and that multiplied by the number of labor plus, let us say, the machines cost a little bit more, 200 taka, multiplied by number of machine is equal to your budget. Okay, mone koro you have a budget of, let's say, 600 taka. ঠিক আছে, let's say you have this budget. তার মানে if you plug in the values in 2 on 2, you get 200 plus 400, that gives you 600, right? Okay, so if you want to plot this graph, how would it look like? এটা যদি প্লট করো তাহলে কেমন দেখাবে? একটু বেশি সময় নিয়ে নিচ্ছি তোমাদের, be patient. Okay, you plot it, it's a straight line, তাই না? ঠিক আছে, এটা হচ্ছে this is your straight line and let us use a different color. ঠিক আছে, so this is actually what your budget line. This is your budget line, or you can call it this the cost line. তাই না? এই লাইনের উপরে তুমি যেখানেই থাকো না কেন, তোমার টোটাল এক্সপেন্ডিচার হচ্ছে 600, and wherever this line touches you is basically the lowest amount of cost you would incur at this point. তাই না? তুমি যদি এর বাইরে আরেকটা কার্ভ প্লট করো, আরেকটা স্ট্রেট লাইন প্লট করো, তাহলে কি হবে এটা? This is your 600, cost equal to 600, and if you have cost equal to what, এখানে কি হবে? দুটো লাইন parallel because you are operating in the same market. So if your cost line is moving farther away from the origin, then the value of the cost is higher, right? This is about straight line. Maybe this is about C equal to 1200. Follow করতে পারছো? Follow না করতে বলে question করবা। তুমি যদি দূরে যাও তাহলে cost তোমার বেশি, that means you can afford more money, but তোমার একটা cost line যদি তোমার দুটো পয়েন্টকে টাচ করে, let's say it touches 2 points on this isochron line. One is point B, another one is point B. And let us assume that this is 1000 টাকা, ঠিক আছে? Point B touch করলে 1000 টাকা মানে কত হয়? না, 700 টাকা, let's say different values. 700 টাকা। পয়েন্ট বি তে, ঠিক আছে? পয়েন্ট বি কে বি ইন্টারসেক্ট করছে কস্ট ফ্যাক্টর সি তে, তার মানে তুমি যদি প্লাগ ইন করো এই ভ্যালুগুলো 1 and 5, you plug these in values in. Labor 100 into 5 gives you 500, plus 200 gives you 700. So this point B falls on this cost line. This is the cost line. তোমার খরচ হচ্ছে কত? 700 টাকা, তাই না? You are spending 700 টাকা, but how much are you producing? The same, right? সবাই চুপচাপ হয়ে আছো, তার মানে maybe something is wrong. Either you are not listening or there is some issue with the internet. আচ্ছা, তাহলে যেহেতু A, because you have A, B and C, all of them are on the same isochron line, that means you're producing the same output. Okay, but if you're operating at point B, your cost is 700 taka. If you're operating at point B, your cost is 700 taka. And if you operate at point C, your cost reduces to 600 taka. So which point do you want to operate at?
C.
Obviously at point C. Okay, so to find out what is the optimal, oh, that's fine, you can go, I'll give you attendance. Somebody said he has to go. So how do you choose which point to operate? You look at the cost line and find out where which cost line touches the isochron line. Okay, the point of touch is your point of operation. Okay, now going back to our proposition, everybody has a class. Okay, don't worry, you can go, you can watch the video, I'll give you attendance. Let us look at the point where we left off. Now you are at this isochron line, remember, and you want to go on at the top. How do you do it? You draw some isocost lines. You draw the isocost lines, right? And draw them all parallel. Draw them all parallel to each other. Okay, draw them like that, and then you find the points of intersection. And that is your path of expansion. বোঝা যাচ্ছে? Make sense?
Yes, sir.
Let me use a different. Let's use a different color. This is your path of expansion. This is the expansion path. ঠিক আছে? তার মানে, if you want to project back to this hill that you wanted to climb, you will be looking at not a very straight line, not a very zigzag path. You'll be looking at where these isocon lines intersect, and you follow. Okay, this will not be a straight line. Somehow this whiteboard is not behaving well. I have to take care of it. But this is how we finish your slide today, and the next class you'll have some math problems to handle. In the meantime, if you have time, try to solve these math problems, and this is the expansion line that we talked about. All right, everybody, your patience have been tested today. ঠিক আছে? So I'll give you all of you attendances, regardless you attended or not.
Thank you, sir.
Thank you, sir.
Thank you, sir.